Welcome, ninth grade learners, to a brand new explainer. Today, we are absolutely not just staring at a dry math textbook chapter on polynomials. No way. I want you to look at this as your gamer's guide to decoding the algebra matrix. I'm going to be your universal mathematical architect today, and together, we're going to crack the code on how these abstract expressions actually shape the mathematical world around us. Let's get into it. To conquer this matrix, we've got to beat 4 distinct levels. We'll start with the anatomy of polynomials, unlock the ultimate remainder shortcut, construct some geometric blueprints, and finally, face off against the master challenge.
Okay, level 1, the anatomy of polynomials.
Let's dive right in. Every matrix has its basic rules and stats, and polynomials are literally no different. So try to think of these terms not as boring vocabulary to memorize, but as the fundamental building blocks and power levels of the structures we're about to decode. The variables like x or y, well, those are our changing elements. Their coefficients are their multipliers, basically the intensity of that specific element. And that highest exponent power, that is what we call our degree. It defines the absolute maximum power level of the entire polynomial. So, for instance, if you have an expression like 3x to the 7th minus 4x to the 6th plus x plus 9, that 7 right at the beginning, that tells us we're dealing with a massive level 7 structure.
So it's totally crucial to know how to instantly identify the class of any mathematical object you bump into. If it's just got one term, it's a monomial. 2, binomial. 3, trinomial. Simple enough, right? Then we look at its power level, its degree. A degree of 1 means it's linear, a degree of 2 is quadratic, and a degree of 3, that is a cubic polynomial. Getting familiar with these classes is your very first step to mastering the matrix.
Moving on to Section 2, the ultimate remainder shortcut. All right, now that we've got our basic stats down, it is time for Level 2. This is where we acquired the single most powerful cheat code in the entire game. It's going to let us completely bypass tedious calculations. Think about the slow, frustrating multi-step grind of the traditional polynomial long division bracket. It takes forever, right? And honestly, one tiny little mistake completely ruins the whole thing. But what if we just skipped it? Imagine a digital calculator instantly printing out your answer, totally bypassing all that messy long division. Here is exactly how that cheat code works. If you ever need to divide a polynomial, let's call it p of x, by a linear polynomial like x minus a, you just don't divide at all. Seriously. You just take that number a and you plug it directly into the polynomial. Boom. The value it spits out, that is your exact remainder. It's instant. It's automated. It's an absolute game changer. So let's take this to the next logical step and see how it builds into something even greater. What if you use that cheat code, you plug in your number, and the remainder it spits out is exactly 0? Well, if p of a equals 0, you have just unlocked the factor theorem. A remainder of 0 means you have found a perfect structural match. That term, x minus a, is officially a true perfect factor of your polynomial. You've essentially just found a key that perfectly unlocks a chunk of the puzzle. All right, Section 3, geometric blueprints. We are entering Level 3. Now, what's really interesting here is that we are totally throwing out abstract mathematical proofs for a minute. Instead, I am putting on my visual geometer hat, and I want you to do the same. We're going to physically build these expansions in our mind's eye. Imagine a large square, and it's divided into 4 very distinct compartments. Let's look at identity I. X plus y all squared equals x squared plus 2xy plus y squared. Think of this as an actual blueprint. When you expand x plus y squared, you aren't just shifting arbitrary letters around on a page. You're calculating the total physical area of a large square made of one square compartment of area x squared, another square of area y squared, and 2 identical rectangular compartments of area xy. It's literal space. And that brilliantly brings us to identity 2. X minus y all squared equals x squared minus 2xy plus y squared. Now, if the first identity was all about adding compartments together, this one is the geometric equivalent of carving area away from our master square. We are literally trimming down the edges to find the specific area of a smaller internal square. Then we have identity 3. X squared minus y squared equals x plus y times x minus y. Imagine taking a flat square of area x squared and physically taking scissors to cut out a smaller square of area y squared right from the corner. This identity shows us exactly how that remaining, awkward-looking shape can be perfectly reassembled into a neat, clean rectangle, with sides x plus y and x minus y. Next up is identity IV. X plus a times x plus b
equals x squared plus a plus b times x plus ab. Consider this one your ultimate guide for constructing a rectangle out of entirely uneven side lengths. It perfectly categorizes the distinct rectangular areas that get created when you extend a square's sides by different amounts, say a on one side and b on the other. All right, let's level up our 2D blueprints with identity V. X plus y plus z all squared. We are sectioning off our flat blueprint into 9 distinct compartments of area now. X squared, y squared, z squared, plus 2xy, 2yz, and 2zx. We are adding immense, amazing complexity to our flat blueprint here. Okay, are you ready to jump into the third dimension? Because identity VI does exactly that. X plus y, all cubed, equals x cubed plus y cubed plus 3xy times x plus y. We are absolutely no longer calculating flat 2D area. The power of 3 means we are now building the 3D volume of a physical cube, expanding it outward into smaller cubes and rectangular prisms. How cool is that? Conversely, we have identity VII, x minus y, all cubed, equals x cubed minus y cubed minus 3xy times x minus y. Just like we carved away 2D area a few minutes ago, we are now literally hollowing out 3D space. And finally, we wrap up our rapid-fire blueprints with identity II. X cubed plus y cubed plus z cubed minus 3xyz equals x plus y plus z times x squared plus y squared plus z squared minus xy minus yz minus zx. Wow, this is the ultimate master schematic. It's a massive, complex, volumetric transformation that balances 3 distinct 3D cubes against a shared rectangular volume. Honestly, memorize this shape. It is incredibly powerful.
And here we are, Section 4, the Master Challenge.
We made it to the final level of this explainer. It is time for the boss battle. Every single tool, every cheat code, and every blueprint we just talked about, we have to use them all together right now. Here is our target, the massive cubic polynomial x cubed minus 23x squared plus 142x minus 120. Okay, step 1. We deploy our instant cheat code. We test factors of 120 and instantly find the plugging in a 1 gives us exactly 0. Boom! By the factor theorem, x minus 1 is officially our first factor. Step 2. We divide our massive polynomial by x minus 1, which seamlessly splits it down to a much more manageable quadratic, x squared minus 22x plus 120. Step 3. We pull out our geometric blueprints. We need to split that middle term to find 2 numbers that add to negative 22 and multiply to 120. Those numbers, negative 10 and negative 12. So our final perfectly decoded factors are x minus 1, x minus 10, and x minus 12. Just like that, we've beaten the boss. You did it. You now have the fundamental stats, the ultimate cheat codes, and the master geometrical blueprints. You don't just have to solve math problems blindly anymore. You can visualize them, physically build them in your head, and instantly deconstruct them. So I guess the only question left is, are you ready to take these tools and construct your own reality within the algebra matrix? Thanks so much for hanging out with me for this explainer, and I will catch you in the next one.